Hello, Sandberg Algebra students. Today we apply solving quadratics to geometry problems. Everybody always asks, when are we really going to use this in life? Not necessarily saying you're going to use this in life, but it is an application of quadratic equations, and it involves geometry. One thing you have to first know is if we are giving a rectangle, okay, and I have the width and the length. When we go to find the area of a rectangle, what we do is we multiply the two. Okay, so area is equal to length times width. So, as we go to apply this, the first example, the area of a square is 121 meters squared. The length of a side is represented by x plus 4. They're asking us what is the value of x, then determine the dimensions. And when they say dimensions, what is the length and what is the width? Okay, that's what they mean by dimensions. So, if one side of a square is x plus 4, right, what do we know about all four sides of a square? They're equal. So if this is x plus 4, this is x plus 4. So now they tell us the area, alright, is 121 meters squared. So what we do is we basically take the area formula. Length times width equals the area. What do we know the length is? Well, this here is x plus 4. Times, what's the other side? X plus 4. And if we multiply the length and the width, what do we end up getting? We end up getting 121. Here's the thing. We have to know how to solve this quadratic equation. And the first thing in solving this quadratic is multiplying these two binomials out. So we go and do what we did last chapter by multiplying all these terms, distributing twice here. X times x is x squared, plus x times 4 is 4x. 4 times x is 4x, and 4 times 4 is 16. Remember, this is still equal to 121. When you combine like terms in the middle here, you end up getting x squared plus 8x plus 16 equals 121. Well, if you remember, solving quadratics, our first step is always to go ahead and set it equal to 0. So now I subtract the 121. I end up with x squared plus 8x minus 105 equals 0. Now we are ready to solve. So what method do we use to solve this? Well, we have two options. One, we could look to see if it's factorable, or we can use a quadratic formula. Well, if we wanted to factor it, we'd have to find the numbers that multiply to give us negative 105 and add up to give you 8. Now, what numbers make that happen? Well, negative 7 times 15. So this right away would be x minus 7 times x plus 15 equals 0. Now, I can set each factor equal to 0. When I add 7 to both sides here, I get x equals 7. When I subtract 15, I get x equals negative 15. Well, which answer does not make sense here? Well, if we plug negative 15 back in, we'd get a negative side length. Can that happen? No. So we eliminate that, and we know the value of x that works in this problem is 7. Well, to find the length and the width now, all we do is plug that in. 7 plus 4, that side would be 11. And 7 plus 4, 11. The other side would be 11. Okay. All of these problems are very similar. So again, here, the area of a rectangle is 28 feet squared. They tell you the length is x plus 3. And the width is x. I'll actually write it the other way. I'll say this is x plus 3. It really doesn't matter. And that'll be x. Now, what do I have to do with these two side lengths to get the area? I would have to multiply them together. X times x plus 3 equals 28. Well, now I have to solve this. And again, before I can do anything, I'd have to distribute here. And once I distribute, then I need to set the quadratic equal to 0. X times x is x squared. X times 3 is 3x. And that equals 28. Uh-oh. Is it set equal to 0? No. How do I set it equal to 0? Subtract the 28. So I end up with x squared plus 3x minus 28 equals 0. Now, again, I think the factoring method is the easiest way. If you want to use a quadratic formula, you can, but I feel it's much easier to factor this numbers that multiply to give me negative 28 and add up to 3. That would be x plus 7 times x minus 4. When I set each of these equal to 0, I end up with x equals negative 7 and x equals 4. Which one of these answers makes no sense? Well, the only one that doesn't make sense is the one that involves a negative. So the value of x that works in this problem is 4. But now I have to find the length and the width. Well, if the length is x, I know the length is going to just be 4. But the width, we'd substitute 4 in for x. So 4 plus 3 is equal to 7. Alright. And the last one. Still not much different. The area of a rectangle is 40 feet squared. The length is represented by 3x minus 1. So we'll go 3x minus 1. And the width is x plus 2. So I go ahead and I say, okay, length times the width is equal to the area, which is 40 here. So I go ahead and I distribute now. 3x squared, 3x times 2 is plus 6x, minus x, minus 2 equals 40. And I'm going to do two things at one time here. First, I know these can be combined. So it's going to be 3x squared plus 5x. But I'm going to also set it equal to 0 by subtracting the 40. So I subtract the 40 and I get minus 42 equals 0. Here's the thing. I can check to see if this is factorable, but I would have to use the AC method. This is a problem where it's probably much easier just to go straight to the quadratic formula. So I know A is equal to 3, B is equal to 5, and C is equal to negative 42. So now my discriminant is B squared minus 4 times A is 3 and C is negative 42. When I evaluate that discriminant, I end up getting 529. So now we can go and find the solutions. So x equals the opposite of b, which is negative 5, plus or minus the square root of 529, all over 2 times a is 3. So first we add negative 5 plus the square root of 529, right, is going to be 23, all divided by 6, which gives us 18 over 6, which is 3. In the other solution, we do have to check both of them. Negative 5 minus 23 all over 6. That gives you negative 28 over 6, and right away you should exclude this answer because when you plug it back in, you're going to get a negative side length. So the value of x that makes sense in this problem is 3. Well, the length now we'd substitute it in. 3 times the value of x is 3 minus 1. That would give us 8. And 3 plus 2 is equal to 5 for the width. And we are done. Okay, go ahead and try the other problems on your own. Thank you very much for your time.